This video will show you how to clean and conform geospatial data for the zoning districts you will upload to the National Zoning Atlas editor. Usually, a team's geospatial analysts will be in charge of this task. The information discussed in this video corresponds to Section 5D of the How to Make a Zoning Atlas Guide. This tutorial uses QGIS to demonstrate these steps. If you are using ArcGIS, please refer to the guide for alternate instructions. Geospatial file quality varies greatly between jurisdictions, so before you upload anything to the editor, you will have to work carefully to clean and standardize it. This video will cover 2 techniques that will allow you to do this before addressing 4 special circumstances you may encounter. First, identify slivers. Geospatial files contain slivers, which are unwanted polygons that typically result from previous operations done to the geospatial file. Typically, these will be very small in size, like this example between 2 zoning districts in Connecticut. To detect and remove slivers, first open the attribute table and create a new field in which you will calculate polygon areas. To do this, click Open Field Calculator, name the field Area, set the field type to decimal number real, and input $area for the expression. Once this field has been added to the attribute table, you can click on its heading to sort the polygons from smallest to largest area. If any of them have areas that are very near to 0, they are slivers. Simply delete them by selecting the row, locating it on the map, and clicking Delete Selected Features. Note that the units for this field depend on your project settings. They may be in square meters, square feet, or even square degrees. Often, even once you have removed the slivers, you will still have many gaps and overlaps in your geospatial file. These issues may be treated differently, since gaps may sometimes be intended to reflect features of the jurisdiction. In general, when dealing with small gaps and small overlaps, we can rely on the Snap Geometries to Layer tool. Using the Clean Jurisdiction Boundaries as the reference layer, this tool can snap the entire zoning district layer to these boundaries, resolving discrepancies resulting from improper digitization. To ensure zoning districts are snapped to these boundaries properly, set a conservative snapping distance of 2 meters. Be sure to check that your projection and units are correct when doing this. An accidental snapping distance of 2 miles would lead to some really wacky results. To fix topology for your zoning districts, you will follow a similar procedure as you learned for jurisdictions in the Create and Upload Geospatial Data for Jurisdictions video, using the Topology checker to find remaining gaps and overlaps. When you encounter small gaps, you can fix them by using the Buffer tool to create a small positive buffer, say around 0.5 meters, and then a negative buffer of the same size. After buffering, you may still have some larger gaps left over. Sometimes these are features intended to reflect roads, rights-of-way, or water features. You can reference maps of these features to determine if this is the case. If it is not, the gap was likely produced by improper digitization and should be removed. You can see how we edited this gap here using the Node tool and Reshape tool. Another problem you may encounter is invalid geometry, most commonly when a feature intersects itself. The Fix Geometries tool can generally take care of these issues. Use this tool by first making a topology rule. Select your layer, set the rule to Must Not Have Invalid Geometries, and click Add. Click OK and run the tool. Now open the Fix Geometries tool. make sure the repair method says Structure and select Save to File. Name and save the new layer and click Run. You can check your work by first removing the existing topology rule. Create a new rule with the layer you just made with fixed geometries, and again, setting the rule to must not have invalid geometries. After cleaning the geospatial data following the steps we've just discussed, you will still need to snap the zoning district boundaries to one another and to the jurisdiction boundaries as previously demonstrated in this video. For full instructions on how to manually snap boundaries, refer to Part 5A2B of the How-To Guide. In addition, you may wish to use the topological editing tools to speed up and improve the accuracy of your snapping. Finally, you will sometimes encounter boundary disputes in which zoning districts overlap. This can occur whether they are from the same jurisdiction or not. As we have emphasized, Tiger boundaries for states, counties, and jurisdictions are the most authoritative reference. Where available, you should resolve disputes by snapping conflicting districts to these boundaries. When Tiger boundaries are not available, as will often be the case within a jurisdiction's boundaries, you will have to rely on other reference layers, geographic features like rivers, road lines, satellite imagery, and use your best judgment to most accurately resolve the conflict. To this point, we have focused exclusively on base zoning districts. There are, however, a number of oddball types of zoning districts that do not fit neatly into this framework. It is likely you have encountered overlay districts, planned residential developments, unmapped districts, and external or fringe districts in your overall zoning analysis. For instructions on how to prepare their GIS files for the editor, please consult section 5D3 of the How-To Guide. We also encourage you to contact the NZA team directly, as these district types may be challenging to correctly format. That's it. Thanks for joining us for this tutorial for the National Zoning Atlas.